Hello, everyone. It's 9:55 now, so I guess we can begin. Thank you for being here. Thank you for coming to this track and wanting to learn more about the CHIPS Alliance. It's a very exciting new initiative that I have the pleasure of representing as chair of marketing and outreach. So you'll get to see me quite a bit if you want to do something with chips. I'm very happy to collaborate with both OpenPower organization, but mostly with all of you as people that are excited about open hardware. Please do, I didn't put my email here, but I'll fix that. Please do reach out. Please make sure that if you have questions, ask out. Like, we have a long session in front of us, and I don't have like zillions of slides, so I guess if you have any questions and something to say, feel free to interrupt me, and we can make it into more interactive session. So chips. I'll tell you what it is, and also I'll try to tell you how we can collaborate, because that's what we're here for. Thanks for Hugh and the foundation for inviting me to speak. I think it's very important that we should kind of try to pool our resources together and kind of cross-promote all the great things that OpenPower is doing through CHIPS Alliance and vice versa. The agenda is like this. I'll try to keep it short on all of the sections, and I think the important ones are kind of who we are in the first place, and of course, at the end, I'll kind of talk a little bit about how we can collaborate better. I put this slide, initially it was like part of a bigger slide, but I took this out and put it on a separate slide because I think it's really, really important. A lot of people ask us, okay, why did you go and found CHIPS Alliance, right? Why would you have yet another organization focused on open hardware? It's a very good question because, of course, more organizations make it kind of harder to follow all of them and so on. But what we as CHIPS decided to care about is an unlimited, so to say, focus on open designs and open tools that are also of high quality and reusable, and we don't focus on a single architecture, we don't focus on a single use case. Of course, based on who you are, what company you're coming from, you might have preferences or there's some kind of focus area, but the organization as a whole is focused on doing, I would say, commercially viable open source stuff in open hardware. And we're working both on the design and IP level, like basically trying to produce collaterals, system-on-chip components or entire system-on-chips, interconnects, and so on. That's the one side of things. But equally important is how we get to those collaterals. And I'm kind of also personally on a quest to reinforce this message where we also want a fully open design methodology to be in place that produces those collaterals. Because if we only have great open source IP, but no way for this student out there or this person in a startup to reproduce it themselves or improve it, it's really not that useful. It's useful, of course, but it's useful for big companies working together. And they've been working together anyway, of course, using various other means. But we want this collaboration that's kind of broader than just a few big guys getting together and deciding the fate of the world. We want this collaboration where people can just work together as engineers, regardless of where they come from. And it's all very easy because there is an open methodology in place, an open mindset that kind of builds those things. So I think it's really important that CHIPS is not just about open source IP per se, but also how to get there. If we look at the people who make up CHIPS Alliance today, and of course our aim is to grow this organization very quickly. We have a lot of very good prospects on many big companies joining. Some of which might potentially be in this room. But we already have a pretty strong founding team with Google, Western Digital, Esperanto, and Sci5. You'll probably know Google and Western Digital for sure. Western Digital is a big sponsor of RISC-V. They're really committed. And obviously, those two organizations also collaborate. Sci5, you probably know from their RISC-V work. Esperanto might be less familiar, but these guys are also kind of building high-quality, high-performance RISC-V designs. They're just a little bit more secretive than the sci-fi guys, right? But they've joined Chips Alliance, and they're helping us do good open source stuff. Since the founding members created, as you can see, there's been more people joining, including Antmicro, which I represent. But there's also Alibaba, Imperas, Codesip, and Metrics. And there's also people that, like, we made it possible for single individuals to be part of the organization, because we know that sometimes it's not that easy to make your organization join, but as a person, you might want to contribute. So we try to make it easy for people to be able to influence the foundation if they have something interesting to say, if they have some good technology they want to contribute. We don't want this to be entirely dependent on companies. But ultimately, we're a company-driven organization. So we have a governing board and so on that's driven by those big players. So once again, Chips Alliance is an org that both hosts and develops high-quality open source. And of course, we mostly mean hardware, which would be IP cores, entire SoC designs, interconnects, but also this open source software development tools for design and verification, simulation, all parts of your daily workflow. We'd like them to be open. So wherever there's a missing piece, Chips Alliance will try to kind of get that missing piece in place. And we want to create an environment for collaboration that doesn't just stop there. It's not just technical deliverables. It's also ecosystem level things like standards, a framework, like legal framework for working together. We actually have a legal committee in place, right? Which it's very hard for a single company to decide what exactly is legal or not, or allowed, or what are going to be the implications of open sourcing a given piece of hardware with NDAs and PDKs and foundries and all these kind of fairly complex legal problems that happen in open source hardware. You need that support, and we have that support in place. And of course, we're looking to build it out and kind of make it even more important. But I think it's a good thing that since the very beginning, we have a focus on this already. We already have a committee in place because the companies that make up Chips Alliance realize that it's important. And I think realizing that it's important is the first step to doing it right. And of course, in that aspect, we definitely want to collaborate with OpenPower, RISC-V, and other people, FOSS Foundation, for example, who also care about how do we produce good licensing models and, generally speaking, good collaboration models that don't hit us in the back later. Hopefully, we're on the right track to get there. We use the Apache version 2 license because, like a lot of lawyers had said, it's good for open hardware. So kind of by default, if you find some open, some Chips Alliance open IP out there, it's probably going to be Apache licensed, although, of course, it kind of depends on the original projects that make up things and so on. But we try to be Apache 2 or at least compatible. So you'll basically mostly be looking at permissively licensed open source. We believe in kind of letting people do things that they want to do and not necessarily forcing them to be open source, but rather wanting to be open source. Having said that, like some of the tools we're working with are GPL. It's kind of definitely a diverse ecosystem that we don't want to kind of drive over with a steamroller and turn into Apache v2. It's more like we will naturally gravitate towards something like Apache v2 for new projects or whenever we have the choice. So yeah, and ultimately it all boils down to getting shared resources like pooling money and pooling time, and so that building new hardware isn't such a pain and such a long process. And yeah, that's why I also think it's kind of very useful to collaborate between those open source focused organizations in the hardware area, because if we can kind of make each other more aware of what everyone's doing, we'll lose less time reinventing the wheel. So what's not to like? The goals of the project, to kind of get a little bit more specific, is first of all to create IP, create or foster or empower, right? It doesn't necessarily have to be creation from scratch. It can be contributions to existing projects. but the kind of building things that are broadly used. We're not talking this random UART IP, we're not talking, I mean, even though these are important, interesting, and useful things, we believe that we have to curate the things that are chips so that we target things that are actually of high value, high importance, and very difficult to do otherwise, right? Because, so that's why you're going to see like PCI Express, DDR, high-speed interfaces as the focus area. Not because we don't like UARTs, right? It's because we feel that those kind of elements are much harder to implement in an open way and historically have been a problem. So we're going to tackle those problems and really try to make a difference, not just be another organization that does a few things and then drifts off to, whoever wants to do something does something, but we're going to actively focus on things that are hard to break them down into pieces, co-fund them in some way, or help people collaborate around them and ultimately break down those barriers. So kind of reusable IP blocks. And of course, it says RISC-V cores here, but of course it should say open source cores. It should say OpenPower. This is completely architecture agnostic, right? Chips is not focused on RISC-V in any way. It happens to be comprised of companies that do RISC-V, but actually many of them are also part of OpenPower and so on. It's definitely meant to be vendor neutral, agnostic, and actually encourage collaboration between RISC-V and Power as well. We're also looking at stuff like neural network acceleration. We're talking about those interconnects that you need to pool different kinds of chips together. And also, we're looking at verification. We're looking at building things that have been verified to work. So unsurprisingly, there's a big focus on the verification. There's a big focus on making sure we have an open and transparent methodology and tool set in place to build verified components that other people can also verify the way we do, right? So it's all about this transparency. So yeah, those kind of validated blocks. We also want to kind of foster especially stuff that is actually being actively made. For example, I'm going to talk about Swerve core, and this one is a real IP that has been taped out. It exists, it works, it's fast, it's good, so that other people, when they adopt this, they can have some certainty level that, okay, if I choose this, I'm not going to end up with something that's actually not possible to manufacture. It has been manufactured, and I can rely on it being kind of verified. And yeah, then the last bullet is kind of software development tools. And of course, I was talking a lot about verification, but there's so much more. There's simulation. There's, generally speaking, the software ecosystem that you have to build on top of open hardware is also hard. It's also kind of difficult to do right. And we want all kinds of development tools to appear, and we're making some of them appear already, and we're planning to kind of build others, so that people can just collaborate and build things in an easier way. And one of the things we're doing, we're also enabling like cloud-based verification, design verification services. But what I would like, as leading marketing in that organization, what I would like to stress is that it's not just about the cloud. It's not just about making things available to people. Like it's easy because it's point and click, and then it all works, right? We don't want to actually wall off people in different cloud ecosystems where to do this, you have to log into that cloud, and to do that, you have to log into this other cloud. We actually mean open source tools you can use on your desktop, but also happen to be enabled in the cloud, right? So I'm all for getting things to be really simple to use, but the important thing to understand is that you also have to make it open and accessible to everyone, even if they don't have an internet connection, right? I mean, of course, the lack of internet connection stops really being a problem these days, but what if you don't want a cloud account somewhere, or it's not useful for you because your workflow includes a lot of tools that you have to integrate. You can't just integrate things like between several clouds, or at least it's super hard to do so. So this kind of cloud-based design verification, I think we should all agree that it should be based on open source tools as well. But yeah, we also want to enable radically new models, because having open source, you're able to make people collaborate and work in different ways than before. The hardware ecosystem historically is super proprietary. There's just so much stuff that is there. It's very difficult to get people off those tools and start using open source. So one of the ideas behind Chips Alliance is, why don't we offer additional value? Why don't we come up with new flows that are radically different and radically better, so that we can show it's not just about having the same thing but open. Sure, it's useful to have the same thing but open, but we're actually looking at what can we do better? How can we leverage open source to make things radically better? And I'll show you some of that stuff soon enough. And one thing that's listed here is Python-based design verification. So there's a tool called CocoaDB that we support and help develop and integrate with other tools, where you just write Python programs to verify your designs. And of course, some people might be appalled at the idea, but most software developers are actually super excited. Oh, I can do verification now. I can write a Python program, I understand what it does, and it works. So we want to enable that kind of thing. And of course, we also want to help people develop new business models for open source hardware. How do you profit from this, right? We don't want to be just breaking down barriers. We want to also be building ecosystems and business models and business for our members and also other people who want to use our IP. So yeah, this has already been mostly mentioned, right? So I won't repeat it again, but we have, haven't mentioned mixed signal yet. We're also kind of interested in that. Of course, a lot of our work is, at least currently, in the digital space, but to build ASICs, you actually need both ends. So we're definitely extremely interested in enabling open source analog and mixed signal IP. So bear it in mind that we're not just about digital stuff. And I'll show you one project that we have that's specifically around that. So yeah, that has been already mentioned, so I'll skip this. Now, this sounds all really great, but how do you do it? And we decided to kind of leverage the Linux Foundation with all their experience and all their involvement and personnel and event organizing capabilities and outreach to help us to do this. We felt that building Chips Alliance as a Linux Foundation organization just makes so much sense, because the task ahead of us is just very, very hard. And the Linux Foundation is already helping out, to a great extent, and I'm pretty sure as we go forward, this is going to get even more important. And so yeah, we're part of Linux Foundation, and we have a governance structure in place that's also being co-designed with the Linux Foundation. We're looking at procedures, kind of making sure that we're not too hastily deciding things that are bad for the ecosystem in the end. And I think we're doing a pretty good job, and the Linux Foundation is kind of leading us by the hand in this. So the Linux Foundation is especially focused on events organizing, which is part of outreach that I'm working with. But also involved in the legal team I mentioned to you, as well as just kind of operations and finance. So all this administrative stuff gets handled by them, I think, to our great benefit. Looking from the top, we have a board of directors, of course, who is comprised of 5 people at this point. I think we're going to have up to 11 directors eventually, but this is still kind of being decided. The reason is, of course, we have a lot of big organizations who want to join us and who want to govern and who want to be part of the governing board. But currently it's 5 people. Zvonimir, who's extremely active and helpful in finding new members and getting the word out there. And also our chairman, Richard from Google, who's our vice chairman, also really helpful and supportive of our events and all that stuff. And we have Mr. Key from Alibaba, Dave is from Esperanto, and Yunsup comes from Sci5. Some of you might know Yunsup from his role as CTO of Sci5. So that's our board of directors. We have an interim director, Ted Marina, also from Western Digital. Ted, of course, has super nicely volunteered to fill this difficult role, but we are actively looking for a director, a real executive director that's gonna lead us. So if you know people that could do great in that role, feel free to recommend them, and we'd be very happy to see if they match our needs. We also have a technical committee, which of course is like the most important. That's why I'm leaving it for last. So the technical committee deals with all the technical developments, and we have Henry Cook in charge of that one. And then we have different work groups for different things. Now, the work groups I'll talk about a little more later, but they focus on different areas that I mentioned, and each of them will also have a leader, and those leaders ultimately end up having, I'll get to that. What's important to note is that ultimately we might want also to have some people working for chips, just doing chips stuff. So those verification engineers, software engineer roles, we don't have that today, and we might not get that in the end, we don't know, but there's an idea that perhaps there's some people just helping out with doing things. The practical, physical, technical things. So yeah, I told you about the governing board. The technical steering committee is something that's kind of gonna be built from that Henry Cook is leading, and as we gain critical mass, we're going to be building a strong technical steering committee just like Zephyr has, for example. It's been very inspiring to participate in the Zephyr TSC and seeing how it works. Definitely a lot of lessons to be learned and kind of procedures to be just copy-pasted, more or less. Outreach committee is, of course, myself and anyone who wants to help. Currently, it overlaps pretty strongly with the governing board. And then there's different work groups for specific aims. And as I mentioned, it's all Apache v2. We have documents in place and to kind of guide the development, and we'll be working on constantly improving those documents and legal base for our operations. We also collaborate with the FOSS Foundation quite a lot. FOSS is more individual-based and kind of oriented around community building, so it's a natural fit. But ultimately, of course, they're not very corporate, so I think it's a pretty good match. And we tend to, for example, organize events together, and many of the FOSS people actually participate individually in chips. If you don't know, FOSS is like Free and Open Silicon Association, which is mostly like Europe-based and about community building and so on. OK, so basically, if you want to be a member, it works kind of like everything else in Linux Foundation. So we have Platinum, Gold, Silver, Auditor, and individual members. I told you about the individual members before. Auditor would be universities and so on. And for companies, you have Platinum, Gold, and Silver. Antmicro is Gold, right? There's a few silver ones, and the founding members are the platinum ones. It doesn't mention fees, but I mean, if you're interested, I think currently it's 25K for platinum, 10 for gold, 5 for silver. But you also have to be a member of Linux Foundation, and that's a little bit confusing sometimes. Is the price we pay for having Linux Foundation come to our aid in all those difficult things. So if you're here, chances are your company might already be a part of Linux Foundation, then it's no problem. You can just join Chips, and actually joining Chips becomes super easy because the Linux Foundation supplies like 80% of the paperwork, so to say, and then the Chips Alliance is just overhead on top of that. But if you're a member of Linux Foundation, joining Chips should not be a very difficult procedure. So these are some events that we already, one event that we already did in June was held in Mountain View, very successful. We had I think we had like 200 people there in the room at Google. And we could see this collaborative energy, people coming from different backgrounds, and we want to continue with that momentum. It's kind of similar to RISC-V. the early days of RISC-V, right? Where people used to just meet because they were excited about RISC-V being there. So Chips is trying to kind of capitalize on the same kind of energy. This slide is not up to date for the Bay Area event. Eventually, and I have another slide, fortunately. So the Bay Area event is actually happening in January now, but I'll tell you about that later. So why don't we skip to the work groups? Current work groups, you're all very interested, of course. What are we doing technically, right? And my answer is, we're doing quite a lot, but this is just scratching the surface. We will be doing much more, and there's stuff in the works that we can't yet talk about because there's legal stuff and so on. But generally speaking, this is just scratching the surface. I think a lot of the work right now is focused on tools, because you need tools in place to produce good stuff. But we do want a lot more in terms of IP, a lot more about system on chips. That's not yet there, but it's going to be there. In terms of cores, we have one very good design from Western Digital called Swerve. That's a verified, taped out, MCU design that really has very strong performance characteristics. It covers the embedded space. But of course, we're super happy to add all kinds of cores, like power cores, OpenRISC if someone has one. I doubt it, but in general, we're not focused on RISC-V specifically. So the cores work group is going to look for other strong contenders to kind of incorporate into the working group. But we're not going to just go and aggregate all the cores out there, right? Because that's not what Chips is about. Chips is about kind of finding key focus areas, key contenders, and making them even better. That's kind of what we want to do. Tools-wise, there's a separate Chisel working group, which might seem a bit weird, but the Chisel group is just big already. Like Chisel is a language for designing hardware. People at Berkeley, Sci-Fi, Google, and a few other places, Antmicro too, are quite excited about Chisel, designing hardware on a kind of higher abstraction level, more modular and so on. So Chisel has its own working group because there's so many people already in the Chips Alliance already working with Chisel. That it's kind of, they would dominate the tools group if we didn't kind of give them their own space. And there's interconnects. We have two, OmniExtend, driven by Western Digital, TileLink, driven by Sci-Fi, but it's actually a lot of people collaborating around these two. So yeah, those kind of two standards are already part of Chips, but we're looking at collaborating or incorporating other things that kind of make sense from a perspective of covering various areas. So yeah, I mean, the conclusion, I don't need to really get into details here. You all know that collaborating around hardware is a good thing and gets you there faster. So just remember that Chips Alliance is like open source, but not just any open source, actually high quality, validated, and built with open tools. And I think the more interesting part is our current project, so I'll skip straight to that. Firstly, that's kind of a slide that sums it up. So we have some blocks already, like Swerve. We have Rocket too. It wasn't listed on the workgroup slide, but actually Rocket is this Chisel-based implementation of RISC-V cores. It's like toolbox for generating RISC-V cores coming from Berkeley. And that's part of Chips today as well. But then there's interconnects and design tools already kind of in there, and RTL simulation design verification tools. So I'll skip straight to the slides mentioning those. First of all, Swerve. As mentioned, it's a high-quality design from Western Digital. It's a 9-stage pipeline core. And I'm not a hardware engineer myself, so I'm not going to get into the detail of this, but it's been proven to have the performance that's really kind of competitive in that space. And it's also been taped out, and you can just take it today and build a chip on top of it, and it's just going to work. Yeah, and it's in large volume production. So it's not just kind of taped out as in there have been 5 test chips. It's being used in Western Digital's hardware at scale. So if you look at Swerve and kind of what it wants to do what Western Digital and people collaborating in that working group want to do, it's not just Swerve, of course. There are other designs, like those boxes signalize where they lie in the high performance scale that are in the works. So there's going to be multiple IPs on different levels that are kind of affiliated, so to say, with Swerve Core that are going to be part of Chips Alliance soon. And of course, we also have Rocket and Boom. And we also list all the pulp cores here. Of course, these are not part of the Chips Alliance, but we also collaborate with them. So you can see on the performance spectrum and timeline where these things are located. And as you can see, in 2020, we're going to have a very exciting time ahead of us because we're going to be pushing out some more really good cores. And next up is design verification and co-simulation. So another project that's a collaboration between Google, Imperas, and Metrics is test and it's called a stressful transaction instruction generator. And what it does is basically tries to verify a core by stressing it enough and putting it through a lot of corner cases and seeing if your core actually sustains this. So it's based on the UVM model, and it's basically a cloud flow. But the important thing is we'll be focusing on making sure that this cloud flow can be replicated on the desktop as well. Then it's OmniExtend. It's a Fabric 2, and it's based on the physical interface of Ethernet. It's kind of supposed to connect different kinds of CPUs, GPUs, memories, accelerators in a cache coherent way. And of course, this is of high interest to people like Google or Western Digital, but also a lot of people at OpenPower, because you want this very tight connection. And Ethernet is a nice standard because it's physically very proven. So I won't get into details of what OmniExtend exactly is, but you'll find us demoing it at all the events. We'll have a demo for sure at the RISC-V Summit if you happen to go there. We'll have, OmniExtend has already been shown on various shows. And if you're interested, of course, you can get in touch and talk to Zvonimir about it. I'm sure he can give you all the details. Then this is a cool demo because it's showing several physical RISC-V chips connected, and they're in the system, like there's been Linux booted on this via OmniExtend, and you get 12 cores, and I think it was actually 8, but they're numbered from 4. So you get eight cores that are actually two physical 4-core RISC-V machines, just connected over OmniExtend. Another thing that we're working with is how to put together IPs to produce high-quality designs, and FuseSock is a project that we adopted for it. It's a package manager and build tool for HDL. Go ahead and try it out. It can take libraries and cores and just generate, churn out an SDK, let's call it, right, for open hardware. SDK sounds bad, but of course we mean open source SDK. So VeryLater simulation capability, interfacing with simulation tools, all sorts of things you need for development of FPGAs and ultimately ASICs. VeryLater has also been kind of incorporated by Chips Alliance because we believe VeryLater is awesome, and you can do quite a lot of interesting things in the borderline between hardware and software. Where you have a good and fast simulator like VeryLater is, you can really innovate in terms of how fast you can build hardware. And VeryLater has been adopted across many organizations, big and small, and incorporated even in proprietary workflows. And it's a great tool because it's really fast compared to many other simulations, and it's just C++. So it makes it very easy to just plug into other tools and make them work together. So VeryLater and Wilson Snyder, who's in charge of VeryLater development, are kind of part of Chips now and collaborating with us very tightly. And we have a roadmap to enhance VeryLater to be this kind of de facto standard tool for simulation. And as you can see, perhaps one of our interesting goals is also to enable VHDL and like other languages, right? I mean, this is of course something that still needs work and sponsorship and so on, but we do want to enable different kinds of workflows, not just the ones that we are using. Because of course VeryLater today is about Verilog, and it works for people working with Verilog. By the way, Antmicro is also adding like system Verilog support into VeryLater. So there is some already, but we're kind of making it production grade. So if you're using system Verilog, for example, watch out for development in VeryLater. It's going to support good stuff very soon, and VHDL hopefully as well. And we want to enable like full UVM-based design methodology inside VeryLater as well. And this kind of last project that I want to mention is the Berkeley analog generator. This is actually analog stuff. This is a generator kind of like what Sci5 did with Rocket for generating cores, so digital stuff. There's a group at Berkeley, and there's also a spin-out from Berkeley called the Blue Cheetah, who's working with this observation that in analog design you do a lot of repetitive work. So they build generators that allow you to just work on a high-level abstraction and generate the analog circuitry that normally you'd be just kind of tweaking by hand. So they want you to tweak this higher level description rather than hand optimized stuff. And it actually works. Like it actually does really good stuff, and we're working with them as well. Like also at Antmicro, kind of, and looking forward to doing more open source hardware with open source analog in it, right? This is going to be pretty exciting. So getting to the end of the presentation, I think a very important aspect of chips is the open hardware like ecosystem aspect of things. And that's why we're here. We want to collaborate with OpenPower. We're collaborating with other people as well. And we see this as like not a competitive exercise, but it's a very, very kind of collaborative thing. And we want to make tools open, and we want to make ecosystems just cross-pollinate each other. So yeah, as mentioned, there's events that you should join us at, and also if you want to speak, absolutely, we're super happy. We'll take you in as a speaker. Of course, like assuming you're going to talk about interesting things, but I would say that probably anyone in this room has something interesting to say about open source hardware. So do get in touch with us and propose talks, and if you can't speak, of course, do come, right? You're kind of invited. Our events tend to be free or very low paid, so it's not like, of course, it's a travel problem most of the time, but financially it's kind of not, it's not a big strain. Design and verification event in Munich, upcoming this month. In Germany, we have the Technical University of Munich hosting a small workshop. It's going to be probably between 50 and 100 people. But if you're into design verification with open source tooling, just come, and it's free to join, I think. You know, free food. But if you have something you want to say in this field, you're kind of invited. We have already a number of speakers lined up, but we definitely have room for more. Chips plus Chisel event, that's the one that was supposed to take place in October, but we realized that there's just too much stuff going on, and January is a better time. Plus, we could join together like Chips with a Chisel event. Chisel is kind of an independent entity as well, so it's going to be a joint event where we're going to talk about chip stuff on one day and Chisel stuff on the other, and people don't have to travel twice. So yeah, do come, do present, either here in Europe or in the States. So how can OpenPower and Chips work together? Well, we already are, right? But we definitely want more of that. So I like it that on the personal level, I mean, many of us kind of know each other, and people just kind of started doing things. Microwatt has been mentioned a lot throughout this workshop, and I think it's kind of cool that you went and did that, because that's exactly what you need, those kind of reference implementations, however they come up, and whatever brings them to life, whether it's a hobby project or someone's just personal endeavor or just some offshoot of some other commercial activity or an actual commercial project, you need those kind of references because you can then combine them, start working on enabling, Zephyr on PowerPC, and then making microwatt work, sorry, on OpenPower, making microwatt work with Litex, which we're right now trying to do. Litex being an open source FPGA targeted system on chip that includes, RISC-V CPUs, but also open RISC CPUs, lattice micro CPUs. You can mix and match different kinds of CPUs into that open SoC. So right now you can also put in a power CPU, and immediately you get an access to a bigger ecosystem. You have IPs for Ethernet and DRAM and all sorts of cool stuff around that the power ecosystem doesn't have to build because it's there, right? So you don't have to reinvent the wheel. And we're already working around tools, and I think that's going to be a very lively conversation. So there's already FuseSock and VeryLater, Edelweiss and Yosys that's being used by some of the power folks, like Michael and Anton here. VHDL is what, of course, IBM and people working with VHDL would use for simulation. Many of the chips people will be doing VeryLater. How do we interoperate those two? How do we make them kind of fully replaceable between each other is an interesting thing. Antmicro is working with our simulation framework called Renode, where we're also enabling OpenPower to be simulated. So very soon we'll have microwatts supported there, and you'll be able to, again, mix and match between RISC-V CPUs and Power CPUs and other architectures, and simulate something like Litex with PowerPC functionally in software for software development. So some of the things that we could immediately start doing, and there's zero cost, is first of all coming up with logos for those projects. Please, if you know someone who has the capabilities to help us design those, that would be perfect. No, I'm joking. This is a side quest, of course. It's for sure. It doesn't really hurt not having logos, but it's so frustrating preparing slides that some of those projects will have a logo, but many of them will not. But more importantly, evangelizing that open source is viable for commercial activity. And that's the last thought I want to leave you with. Open source, the opposite of open source is not commercial. The opposite of open source is proprietary. And I heard Kate speak earlier today, and she said, hey, we're doing all this open source, but we're also working to enable commercial tools. I was like, no, red light comes up. It's like open source is already there being used commercially, and it's going to be, and we want it to be. So go out and say, if someone says, hey, it's either open source or commercial, say, no, it's open source or proprietary. It's all just about the access and openness, but commercial can equally be open source, and we actually want commercial to be open source. We want everyone in the commercial world to be using open source tools if we can. So please go out and say, hey, open hardware is viable now. We can build stuff with open source tools. We can reuse open source IP that's there for us and build awesome things together. Thank you very much. That's everything.